afternoon, sir.
Sorry for the late start. All right. We have been talking about a few things, but I want to deal with mathematical formulation. That has to do with square matrices. So, for example, the one that topic is functions of a square matrix.
Sir, probably I should have let me record it, you know.
Oh, yeah.
Mm-hmm.
Foliage, I forget.
All right.
All right, so like I said, it's straight mathematics we're talking about for the first couple minutes, where we talk about how to find the functions of a square matrix. So meaning to say, e to the 8 is a function, a to the raised to the 20 power is a function, sine a is a function, sine of a matrix. So how does that work? All right, so we want to look at how we sort out that, and then we want to look at formulation with respect to matrix and how is it that we go about solving whatever matrix problem we have, or different ways in which we go about solving matrix problems that we have. So when we want to find any function of any square matrix, there are two things that we have to find. We have to find the eigenvalues first. Anybody remember how we find eigenvalues?
Yes, sir, in a Matlab.
Apart from by hand, please. How you do it in a Matlab, by the way?
The EIG function.
Well, let me put that in here. All right, but by hand, how we find the eigenvalues of a matrix? You would have no Matlab.
No, hard to remember, sir.
A determinant of the matrix minus lambda times the identity matrix or something like that.
Exactly so. So we're going to solve lambda I minus a equals 0. That is the equation that we need to solve to determine the eigenvalues. So lambda I is the 2 by 2 matrix, so it's 1, 0, 0, 1 minus A, which is 0, 1, 2, 4. That determinant must be equal to 0. So that is going to be lambda 0, 0 lambda minus 0, 1, 2, 4 equals 0. So lambda minus 0 is lambda. 0 minus 1 is minus 1. 0 minus 2 is minus 2. Lambda minus 4 is lambda minus 4. And find the determinant by multiplying across. So that is going to be lambda minus 4 minus 2 times minus 1 equals 0. So that's lambda squared minus 4 lambda minus 2 equals 0. So Matlab roots x is equal to 1, negative 4, negative 2, roots x. Tell me what are the roots of this? Should I have Matlab downloading? Should I read it?
X is equal to 1, negative 4, negative 2. Uh, 4.45 and minus 0.45.
All right. So from there, so these are my eigenvalues. Same thing as the roots of the characteristic equation. All right. So now, second thing, find eigenvectors. But remember, what is it that we solve to find eigenvectors though? All right, was the Matlab command? So Matlab, right, V D equal EIGA, And it will give us the eigenvectors. Eigenvalues. All right. But by hand now, the equation that we solve is A times, I'm calling it xy is equal to lambda, which lambda is the eigenvalue times xy. So we're ready to take our matrix A. Zero, 1, 2, 4. XY is equal to 4.45 XY. Now we're going to multiply that out. So 0 times x is 0 plus 1 times y is y. So that's going to give us 0 plus y equal 4.45. 2x plus 4y equal 4.45 y. So we know that y is equal to 4.45x according to this equation here. So we're going to put 2x plus 4 times 4.45. Sorry, what do I want to replace? Maybe simplify my life a bit. 2x carried this over here. So in minus, that's minus 0.45y equals 0. So therefore, 2x minus 0.45 times y, which is now 4.45x, equals 0. So that's going to give me x equals 0. When you found the solution to the quadratic equation up here, so what you got? 4.45 and minus 0.45.
Yes, sir.
Sir, I think make it the other way around, minus 4.45 and 0.45. Not sure still.
Yeah. All right, check it over. 1 minus
All right, so the matrix is 1 minus 4 and minus 2, right?
Yeah.
Yeah, man. So 4.45 and minus 0.45.
Usually it's supposed to work out 0, 1, 2, 4. Four point 45. Point 45x. Two x 4y. Carry this over here because minus 0.45y. Um, 0.45 times 4.45, we just realized. What is that equal to?
$2.0025.
Alright, so this we rounded it off. So this is going to lead us to 2x minus 2x equals 0. And that says 0 equals 0. So what that means is that normally we end up with situation like this. So it means that no matter what value of x we choose, we are going to end up with the same situation. So we can choose any value for x. And whenever we are working out a thing like this, we always end up with that. Because whenever we find the eigenvalues, the matrix that we are working with, the rank is usually equal to 1. And so if we choose the value for x, then we get y is equal to 4.45. Just yeah. We'll get to 7, no problems. All right, so the first eigenvalue is going to be 4.45. Now, when you say Matlab, Matlab is going to give us a different answer. The answer that Matlab is going to give us, let me write it big here, is 1 over 1 squared plus 4.45 squared and 4.45 over 1 squared plus 4.45 squared. That is the answer that Matlab is going to give us for the eigenvalues. All right, because it is not going to choose x equal 1. It's going to do what is called normalize the vector. And when it normalizes the vector, what it does is that it makes sure that the vector, it divides the vector by its length. All right, so it divides the length of this vector is use the Pythagoras theorem, 1 squared plus 4.45 squared. So it's going to divide both vectors by both terms by the length of the vector. And so it's going to be a normalized vector that you're going to see. All right, so just bear that in mind. So the one that you see in Matlab is going to look totally different from the one that you work out by hand. All right, so the next one now is 20124 xy is equal to negative 0.45x. So once again, we're going to get y is equal to negative 0.45 x. We're going to end up with 2x plus 4y equal negative 0.45y. So we're going to carry this negative 0.45. So this is going to give us 2x plus 4.45y equals 0. And if we substitute y equal negative 4.45, we are going to end up with 2x plus 4.45 times negative 0.45 x equal to 0. And as you can see up here, you're going to work out to 2x minus 2x equals 0. So choose Again, that's a trivial equation, so we're going to choose x equal 1. Any value can work. We are going to choose x equal 1. We choose x equal 2, 3, 4, 5, 6. Doesn't matter. So y is going to be equal to negative 0.45. The second eigenvalue is 1, negative. All right. So we're going to make up a matrix called P. P is going to have the first eigenvalue, the second one is the negative 0.45. And the first one is going to be a 1, 4.45. P is our matrix of eigen. All right. Now, the mathematics theory says that A, the matrix that we were doing is P times D times P inverse. D is a diagonal matrix. Made up of the two eigenvalues. And the two eigenvalues were negative 0.45 and 4.45. So this would be 4.45. This is negative 0.45. So the D now. So we're going to ask us to do it in Matlab in a little while. D is a diagonal. So our D, this is one of the eigenvectors. So it's a diagonal. So each of these is an eigenvector, eigenvalue, sorry. And this is an eigenvector. And this is an eigenvector. So our matrix P is made up of the eigenvectors of A, and our matrix D is a diagonal matrix, which has only the eigenvalues of A. Now, any matrix, the other rule is now that the function of A, any matrix function that we want to find, so if we are going to find any matrix, it's going to be P. So, for example, now, let me just write it down. So, e to the at is going to be equal to P write it a little bit straighter. D. Now this is where the function of the matrix come in, not just A now, we want e to the at. So the eigenvalues, the diagonal matrix that we are going to write down, is going to be of the same form as A, but we are going to replace e to the at, but we are going to replace A by the eigenvalue of each of them. So the diagonal matrix that we are going to write down is e to the 4.45t. And the other value is going to be e to the negative 0.45 t. And then the other matrix now is P inverse. But we never find P inverse. What we Matlab is minus 0.45 minus, when you multiply it across here, it is 4.45. Switch these around. Change the sign on the diagonal here. So it's negative 4.45. Sir Campbell, you can just type it in and tell me what the P inverse is. Matlab.
Type, you mean P inverse? Type in a P inverse?
Why you type in P 4.45 negative 0.45, and then you want to type in P, well, inverse P, INV, or P raised to the power minus 1, give you the same answer. Or what else give it? One of them slash P or P, the other way around. I don't remember which one. Any one of them give you the inverse. Easiest one to remember. Well, easiest two to remember are these two.
Sir, P inverse, you answered in the chat, sir.
Yeah, give me a word for doing it. Chat. 0.0918, 0.2041, 0.9082, negative 0.2041. All right. So and we can multiply this out and get a value for e to the at. What about a to the 10, a to the 20? So a to the 20 is going to be equal to the same thing. P and it's the eigenvalue raised to the 20, so that's going to be 4.45 raised to the 20 and negative 0.45 raised to the 20, 0, and 0.0918, 0.2041, 0.9082, and negative 0.2041. Now what about sine A? These three matrices multiplied, so the same thing. P, D, P inverse. The sign of the angle must be in radians. So we just wanted to bear that in mind. Because we wanted to use that to solve a matrix equation in two ways. But we needed that result. Yeah, we'll just take one like a yeah. So before we solve this equation over here, over the left hand side, so you can tell me what is it that would do to solve this equation here for the right hand side?
So that again, sir?
We'll solve this differential equation over here. So
Up
You
here,
mean 3? You mean the
dy dt equal 3y.
so the answer would be 3.
No?
up here, sir. Something like
Yes, sir. Call it again.
change of variable or something like that
Alright.
with him.
Separation of variable.
Separation.
So we're going to carry the y to one side and carry everything else over next side. So we're going to get dy over y is equal to 3. See?
Yeah, maths color another class answer.
Mm. So when you integrate both sides, you're going to end up with ln y is equal to, sorry, not 3t, 3dt. So you're going to end up with 3t plus c. So you're going to end up with y is equal to e to the 3t times e to the c, which we can just write as y equal, because e to the c is a constant, so let's call it, I don't want to call it a, because we're going to confuse. Call it c1 e to the 3t. So basically, if we take as this is dx dt is equal to a x. So our x is going to be equal to some constant which I'm calling c1 e to the a t. Using the same principle. I want -5. So we need to find e to the a t. We need to find e to the a t. So if you can just plug it in Matlab. Let Cooper share the screen and we'll plug it in Matlab and find out all the things that we need to find out.
Alright.
So we need to find out a.
Oh, sorry, I need to allow me for share.
Yeah, I'm looking for it. Each individual may allow for share the screen. Oh, security. Yeah, so a is going to be equal to this 0, 1, 0 square matrix 0, 1, 0 close bracket, close bracket, semicolon 0, 0, 1. -2, -3, -5. And then you have a square bracket now. I put for this capital V, capital, comma, capital D. Just to keep with the equal EIGA. Alright. So the diagonal matrix, wait. I didn't want that. It was my starting example. Alright. So INV V. INVV. So that is is not P, is V. I mean, is not V, is P. All right, so the V is what I was calling P. So now, if I want the eigenvalues of A, that's going to be the V, which is here, the diagonal matrix, which we have here, V inverse, but we're going to raise each of the diagonal values to e to the negative 4.42, negative 2.88 plus 6.076 I raised to the t, and negative 2.880, negative 6.076 I raised to the t, which is going to give me a sine and cosine value for the function. I don't know if you understand what I'm saying.
Wait, sorry, is where you get them values there from?
Where?
Let I just call out all of them.
I wish I could write on the screen. The values, let's see if we can write on the screen. Let's see, they're picking them from high school right on the screen when I teach. So see if we can do that. No, we can't do it. All right. If you look at the D matrix, so the V is what I'm calling P. And the inverse that you have done here as the answer is my P inverse. And then the D matrix that I'm going to use for e to the AT is going to be the D, where's the D equal? Negative 4.4241 is, everybody seeing that? Negative 4.4241.
Yes,
Try
sir.
to do something to highlight it.
Yes, sir.
Yes,
All right.
sir. Yes, sir.
So that would be e raised to the negative 4 point that, and then the one in the middle, the negative 2.88 is going to be e raised to that,
The diagonal, sir.
the diagonal. And the third one is e raised to the negative 2.880 minus 6.076 I. Now times t. Now the negative 6 point, the e raised to the a plus bi times t is really going to give you cosine and sine function if you use Euler's formula. I didn't want to start with that as the example, but no, that was the example that we did have put on somewhere. So if you, when you want e to the AT now as your solution, we go back to so my x is going to be C1, and then it's V, D, V inverse. So the value that I got for V, the value that I got for D, and the value that I got. So the D now, we say is going to be the matrix e raised to the negative 0.4241 t, and the other one is e to the negative 0.2880 plus 6 I think times t, and the other one was e negative 0.288 minus 6. And I said that these will lead to cosine theta plus I sine theta. It's going to be a trig function. All right. So that is one way to solve this type of equation. So we get the function, and then we proceed to solve it out in that manner. But But let me deal with the other way in which we sort out. I'm going to give a general solution and then we're going to do it. So if we take Laplace transform, then this x that is a derivative. So we take is going to have an s. S represents the first derivative. Capital XS is equal to a x s plus b u s, and then y of s is equal to c x of s. So if we take Laplace transform, then those are the things that we're going to have. Now, if we make x the subject of the formula, so now it's going to be s x of s minus a x of s, carry over the a, is equal to and in anticipation of the question, somebody can factorize this for me, please. A minus ax. Not a trick question.
A open bracket 1 minus x.
All right. So now we're going to take out x of s. And we're going to write si. When you ask me where the I come from, I'm going to ask you where the 1 come from here. Taking, we are subtracting two matrices. Matrix A times x of s. So this here has to be a matrix. So we have to put s times, the matrix equivalent for 1 is I. So that's why we put the I, because now, therefore, we end up with a matrix. We're going to carry, we want to make s x the subject of the formula. So, again, not a trick question, but what 3x is equal to what? 3x equals 6, x is equal to what?
Sir, can you go back up 1 second?
2, sir.
Or you get 2.
Divide both sides by 3.
Divide both sides by 3. So I can say x is equal to 6 times 3 inverse, and I get 2. So this xs that I'm going to write here is going to be equal to si minus a is a matrix. So we don't divide by the matrix to get rid of it. We take the inverse. We carry it over to the next side, to the right hand side, from the left hand side. So we're going to write this sx, si minus a, if we carry it over here, then it becomes inverse. So xs is equal to si minus a inverse. So as you can see, the same thing as divide by 3. So 3 inverse is the same thing as 1 over 3. So 6 divided by 3 is the same thing as 6 multiplied by 3 inverse. So we carry over here, it becomes the inverse times B U of S. And I'm going to substitute that in 4. So we get Y of S is equal to C Si minus A inverse times B. So this is what I want to talk about now. So suppose we got that to solve. Then this is my A, this is my B, this is my C. And I have that Y is equal to Si minus A inverse times B U of S. Oh, so if U of T is unit step function, then U of S will be 1 over S. Alright, so now Y is going to be equal to C Si minus A. So the first thing I'm going to write down is what is Si minus A. So that would be S times 1, 0, 0, 1, I minus A, which is 0, 1, 2, 3. So that is going to be equal to S 0, 0, S minus 0, 1, 2, 3. So that is S minus 0 is S, 0 minus 1 minus 1, 0 minus 2 is minus 2, and S minus 3 is S minus 3. So now we want Si minus A inverse. So remind ourselves that if x equal A, B, C, D, x inverse is 1 over the determinant, which is AD minus BC, DA minus C minus B. So this is going to be 1 over S into S minus 3 minus 2 minus 1. Switch these around, S minus 3, S. Change the sign on the other diagonal. That's 2, 1. So this is where we are at presently. At present. All right, so we said that y is equal to c s I minus a inverse times b u of s. All right, so we have si minus a, and now we're going to multiply it by b. Just to make sure, b we have as 0, 1. So we're going to say si minus a inverse times b is 1 over s squared minus 3s minus 2. S minus 3, 2, 1 s times b, which is 0, 1. So we're going to multiply these two matrices. We're going to leave this part alone for the time being. So we multiply, we're going to have s minus 3 times 0 plus 1 times 1. That's 1 over s squared minus 3s minus 2. So our first column is going to be 1. S minus 3 times 0 is 0. 1 times 1 is 1. 2 times 0 is 0. And s times 1 is s. So now, si minus a inverse times b times u of s is going to be equal to 1 over s squared plus 3s minus 2. We're not troubling that. times 1s times us. Us is a step function, so it's multiplied these two. So that's going to give me 1 over s squared, so we put plus minus, minus 3s minus 2. And we'll multiply, we're going to get 1 over s as the first term and 1 as the second term. And then finally, we have ys is equal to c times si minus a to the minus 1 times bu of s. So it's going to be equal to, now my c was 1, 1. If you look here, c is 1, 1. So I'm going to multiply everything by 1, 1. So it's going to be 1. Notice that I'm not troubling 1 over the determinant. There's 1, 1 times 1 over s, 1. So once again, we are going to multiply. So this is going to be equal to 1 over s times 1 is 1 over s. 1 times 1 is 1. So we're going to simplify that. So we get ys is going to be equal to, I'm going to spin this around, so put this s plus 1 over s into s squared minus 3s minus 2. So with that now, is something that we have to convert into y of t. Una awfully quiet. Is either una not bother pay me no mind or
Half last, sir.
But
Huh? Eh?
the board, just a follow on.
Okay.
Sir, he was speaking, sir, but him alone a follow.
Can see if we can so we can
So where I lost from? The beginning?
Good question, sir. When I got
Sir, what you use to determine that it's a step function at that step down there?
No, well, the problem would have to state what kind of function the input is. Whether it's a step function is an impulse function. So I'll just put in that is a step function.
Okay.
Really and truly, we should have put in says an impulse function. But anyhow, so I was saying that if his input is a step, what is the output going to be in real time? So input is a step. So we just write down the Laplace transform for the step function, which is 1 over s. And we say that we already have this big formula that says my output y is equal to c si minus a to the minus 1. The inverse of si minus a times b times u of s. So I just take my time. First thing I write down si minus a. S times I minus a. And we get the simplification. Then we have to write down the inverse. The inverse is 1 over the determinant. So the determinant is s into s minus 3 minus 2 times minus 1. So I ended up with, as my determinant, 1 over s squared minus 3s minus 2. And then so we flip these around, dA, and then we change the sign on these, which I hope I did. Did I? No, I did not. Oh, yes, I did. Change around the s and the s minus 3, and then change the sign on the minus 2 and the minus 1. So that we have here, and change around these two. So I have my SI minus A inverse. Go ahead.
The screen gets a little. Everybody see screen or just my screen?
That's all right, man.
Make it bigger. Oh, we just make it bigger. All right, now.
Come like my screen alone coming. I see nothing. Everybody see?
You gone too big now, sir. Yeah, that's all right.
You still don't see nothing?
So I guess on my screen, go flip it go all one. Where can I go it, sir?
All right, so I multiply by, no, so I have SI minus A inverse. So the next thing is SI minus A inverse times B. So I just tack on B. So this is my B that I just tacked on. So it's a matrix multiplied by a vector. So you know you multiply row by column. So S minus 3 times 0 is 0. 1 times 1 is 1. So that's 1. 2 times 0 is 0 plus S times 1 is S. So you get 1 and S. And then now, so the next step is SI minus A inverse times B times U of S. So U of S, which says 1 over S. So this is my U of S. So I multiply by 1 over S, get 1 over S. And S times 1 over S, I get 1. So after that, then I know when I'm going to multiply by my C, because we said that Y of S is equal to C SI minus A inverse times B U of S. So you notice that I find SI minus A, then I find the inverse, then I multiply by B, then I multiply by U of S, and the last thing I'm doing multiply by C. So I put on C. This is C. It is 1, 1 multiplied by the vector that I have. So it's a row multiplied by a column. So it's 1 over S times 1 plus 1 times 1.
Sir.
Mm-hmm.
We can just can we use a calculator and all of this, or we need to show everything?
No, I'm the teacher, so I have to show everything.
Oh, I think everybody gonna get how I go on here. So sorry.
No, we take it step by step because we are the teacher for the class. If I was a student in our class, then we'll just skip out a whole heap of the step. Just put everything in one place. All right. So now, I multiply and I get 1 over S. 1 times 1 over S is 1 over S. And 1 multiplied by 1 is 1. So that's why I get 1 over S plus 1 over the S squared minus 3S minus 2. So this is S squared minus 3S minus 2. And I simplify that. Simplify the 1 over S plus 1, put everything over common denominator. For 1 plus S over S divided by s squared minus 3s minus 2 over 1. The same thing as put s plus 1 over s multiplied by 1 over s squared minus 3s minus 2. So I am here.
All right, sir. Question. The up to, I think we can follow the once you start the Laplace. But before that, sir, with the eigenvalues and vectors, we not really follow why we did that, all of that.
Oh, all right. So now this Laplace, this is either or. So I was doing an example. So if you are to find CE to the AT and blah 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 blah, then this is one way that you do it with the P inverse. So this now, sorry, this method here with the Laplace is R. So if you get so doing a full equation with this one, with the Laplace transform. So that's why I got the result, and the result say if I get x dot equal ax plus bu, it's not a dot over the u, yeah? Then what is my value for y? So we end up with this as the result for y. So any matrix equation that you have, you can solve it either of the two ways. It's just that if you get an equation like this to solve, then it might be easier for you to just say x is equal to e to the at and then plug it into Matlab and get your p, your d, and your p inverse. Matlab is going to say v. Well, you can just put instead of v. I'm just using the standard Matlab command, but it's p d equal eiga, and you're able to solve it. So it's either or.
Okay.
So if you get this now, then what you are required to do is use this result that is here. All right.
All right. So based on the form that we get the question in, we can choose which one.
No, let me go even further. It's not based on the formula. It's based on which one you prefer to work with.
All right, sir.
Because what you see is the textbook goes the whole way with both of them. When I say go the whole way, I pick a little easy example, x that is equal to, and there's no, the input u equals 0. For the first one to show that how you find e to the at and so forth. But you can use the same Matlab approach just to solve this kind of system that we have. Because if you say sx equal ax, then you can work out what your equation is going to be. You can use the Matlab approach. We're going to send you to go look into the chapter and see what you can make out of chapter. Is it a 10 or 11, depending on I don't remember which version we said it. But it's R. Whichever method you choose is what you use. The only time we have the exception or they are going to have a problem with the R is you go to some university and the lecturer not going to tell you R. The lecturer just going to pick one and work with that. That's what I see. So we are here. So now, if we are here now, we want y of t. So we have to work out what the y of t is. So we're going to let s plus 1, s squared minus 3s minus 2 is equal to a over s plus bs plus c. This can factorize the s squared minus 3s minus 2. So a into s squared minus 3s minus 2 plus s bs plus c is equal to s plus 1. So let s be equal to 0. You get minus 2a equal 1. Every 0, 0 minus 2, everything else is 0. So a is equal to negative a half. Compare s squared. I'm not going to plug in any more numbers. You have as squared plus bs squared. There's no s squared over there, so you're going to have a plus b that means that a plus b equals 0. So negative a half. Well, alright, so that means that b is equal to a half. You're going to compare s. So that is s times c and minus 3as. So minus 3as plus cs is equal to over there the next side is just s. So minus 3a plus c equal 1. So a is minus a half, so that's minus 3 times minus a half plus c equal 1. So c would be equal to 3 over 2. So c would be equal to 1 minus 3 over 2. 2 over 2 minus 3 over 2, so that's minus a half. Yeah, so then don't make a life easier at all. So ys is equal to a, which is negative a half, 1 over s, plus b, which is a half, s minus a half c, plus s squared minus 3s minus 2. Alright, so let me get the Laplace transform table. Before that, we will complete the square and this. So put it over here. Ys is equal to negative a half 1 over s, which we know what that is, plus half s over s squared. Alright, I'm completing the square. S plus is half of this, so half of the 3s. However, you complete the square, s minus 3 over 2, I don't know how the teacher will complete the square. Minus 2 plus minus 3 over 2 squared. plus S minus 3 over 2 squared and this is minus 2 plus 9 over 4 plus minus 4 over 4. I'm doing all of this by hand. You can use your and do it. Plus 5 over 4 minus a half S over S minus 3 over 2 squared plus 5 over 4. Alright, so we could get the Laplace transform table.
Sir, not just a half, sir, no half is.
The 5 over 4 look wrong. It's supposed to be 1 over 4.
Supposed to be 1 over 4?
No, sir.
No, one, sir, that.
3 squared and 9 over 4. Where you get the quarter?
No, sir.
Minus 2 plus 9 over 4 is a quarter. 4 times, you have minus 4 over 4, so minus 4 over 1.
Oh. 9 over 4, that is supposed to be minus 8 over 4. Yeah. Minus.
Yes.
Yeah.
And then the numerator, sir, you have 2 of them as office.
Okay, so this half. Alright, so we'll go for the tables now. I think we're nearly done with them here, right?
Yeah, no, sir.
Yeah, it's control. It's the people who sit down in the AC office and work out numbers, so just bear that in mind. So I'm looking for the table.
So screen down.
No, because we're going for the tables to bring it, cut it out and carry across. So soon come back. It soon come back. Let me keep up the screen. Sorry. While I go for the table. Give me a second here, just so. Sure. Alright, so let me do this now. Alright, so see the ones that we're going to use here. Forget, this is UT equal 1 over S. You forget that UT is also equal to 1. So we're going to use that one. we're going to use b over s minus a squared plus b squared is equal to e to the at sine bt. And then for us, we have to use this one as well, s minus a all over s minus a squared plus b squared is equal to a to the at cosine bt. So I have to use these two and this. So so let me just go back. So we're cool with this one because the square root, if this is b squared, the square root of a quarter is a half. So this one is equal to minus a half times 1 y of t. And this one is going to be a to the minus 3 over 2 t sine whatever is here half t. So this is the problem. And we are saying t greater than or equal to 0. If we don't say that, we have to put in the ut. So this one here, so now, is the problem that we have to go fix up. Because we're going to have to fix up. We have to get rid of this half. And then we're going to have to, apart from getting rid of the half, have a minus 3 over 2 inside here. So all of that is going to create a bit of a problem for us to sort out. Of course, the nice thing about it is that for some situations, Matlab can find the Laplace inverse for us. Let me just look up the command because I don't remember it. You can put in the function and it will find the inverse Laplace for you. But the last time I was showing somebody how to do that. When they finally do it, it was the inverse was 3 pages. The inverse Laplace was 3 pages long. So sometimes it don't really help. But since you're here, we need to just mention how you find the inverse Laplace transform.
Sir, I have a question, sir.
Mm-hmm.
With the sine function, we just find the Laplace inverse, sir.
Mm-hmm.
The formula is e to the at sine bt, right?
Yeah.
So is it a case that we have a half of the numerator, which is b also and a quarter here? We do have to try to make the multiply by a half to turn that into a quarter also.
No, we don't, because remember let me go back. 1 second. Matlab. We just got to. You just give me 1 second. All right. Let me deal with. Here's the thing where it says share multiple screen. All right, you can't find the share multiple screen. So let me go back here. So, all right. Remember now we had a half. Sorry. You see, what happened here?
Sorry, me see it, sir. B square, so the root of the quarter now would have be that, sir.
Right, alright.
Yeah, me see it. Respect.
Alright, cool. Alright, so before, let me just, so now, this thing here now, we have to go fix up this one here, so. Because, first thing, so let me go and fix it up. So we have a half S over S minus 3 over 2 squared plus a quarter. Of course, the easy way to fix up all of these things is just how would I say now? Get a bigger Laplace transform table, but we have to go through the maths because we don't have a bigger Laplace transform table presently. All right, so the transform that we're using for this says e to the at cos bt so this is s minus a squared plus b squared, and this is s minus a at the top. So we have to get rid of the half in front of the s. So we can carry the half outside. So we can put a half, and then that is going to be s over s minus 3 over 2 squared plus a quarter. But now this is our a. So what we have to do is, if we put minus 3 over 2 up here, then we're going to have to add back 3 over 2 with the half outside, s minus 3 squared plus a quarter. See what we're talking about there? We have to take the half, put it outside, and then now, because we have the a that we have to put in the minus 3 over 2 just like the bottom. But if we put the minus 3 over 2 or minus 3 over 2, we have to add back the 3 over 2. So now, all right, so now this is going to give us a half e to the minus 3 over 2 t cos b, which is half square root of quarter t. Fine. But now this now is going to be plus a half, and remember we're up here, so this is 3 halves. 3 over 2 is 3 halves. So we're going to say is 3 times e to the minus 3 over 2 t sine half t. So now my yt that I have up here is going to be minus half times 1 as minus a half, plus a half e to the minus 3 over 2 t cos half t plus 3 halves, which is 3 over 2 e to the minus 3 over 2 t sine half t, sorry, minus e to the minus 3 over 2 from up here, from this portion up here, 3 over 2 t sine a half t. And well, we can take these two and put them together. 3 over 2 minus 2 over 2. So y of t is going to be equal to minus a half plus a half e to the minus 3 over 2 t cos half t. And we will simplify this plus a half e to the minus 3 over 2 t sine a half t. And we have to put in that t is greater than or equal to 0. So that is my final result. And basically, what it's going to look like is that if we have minus a half down here, and it's exponential decaying, so whatever it is, my voltage, my current, or whatever it is, that's what it's going to look like. Because the constant is sine, just say it is oscillating, and this is my DC value. So, like I said, the control guy is the guy who sit down and do all of the maths. And work out all of these things. So today's class was to say how we would work out a particular one of two ways in which we can work out a particular function. I prefer using the Laplace transform method, but we'll have to talk about the other method as well. So that we have a thorough understanding of what is going on. All right. Housekeeping matters. Today is what date? 15/7/22. February, only have 28 days this year. So you're going to stop scrolling.
No, look a bit more. Start from where the line we have right. Yes, sir.
All right. So technically speaking, we have two or three, what we used to call, I don't know if we still call it the same thing now, don't know, out of touch, all people. We have two or three matter lectures still to go. Matter meaning the theory. So we have two or three matter lectures to go. So, so we have to find the you know how the project that we're going to ask you to work on. So after the 2 or 3 matter lectures, then we have to give you 2 or 3 assignments. To sort out for the so one is your midterm. It usually is take home. One is the final, which I'm going to try to turn into multiple choice. So we're going to give you a take home and your midterm take home final. But what we are going to do is give you a multiple choice test based on the 2 things that we ask you to take home. So, and then we're going to ask you to write up a few things. So we have 2 or 3 matter lectures left. A matter, like we say, is theory or things that you have to study or swat, but you don't have to swat anything because everything going to be online. So, and this course, the exams used to be open book anyway, so it was no matter that you have to swat anything. So so next week I post up the first. I post up your midterm, but bear in mind that after you work it out, we're giving you a multiple choice test. And then
Sorry, which platform is there? You
which? I don't send it yet. When I finish fix up there.
So which platform you go to?
Canvas.
Okay.
Canvas.
Okay, cool.
So, all right, we can just bear in mind. So you have 2 more matter lecture left, or 3, depending on what the government say about the pandemic. So if the pandemic continues, then it's 2 lectures we have left, and I suspect the pandemic is not going to finish until maybe next year. I can't do how them behave. Unless people start right, which I think soon start up. Not in Jamaica, but I think the first place is going to be England. But anyhow, let us see. Friend of them say I'll go out. So what I'm going to post up is the site, the Canvas site. And then we're going to talk about, we're going to try and find out how we're going to proceed with the project. So after that, we're going to just ask you to work on a project for us. All right?
All right.
Yes, sir.
All right, so we're stopping there for this evening. Don't bust on the head anymore with anything else. So, all right, good bit.
All right, sir.